Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and I'm here with Joe Gersey, President and CEO of Information Systems Laboratory. Welcome, Joe.
Thanks, Patrick. It's great to be with you.
So ISL is a global leader in sensor technologies, modeling, simulation, and training systems. And you've recently announced a new advanced hardware-in-the-loop RF test system for electronic warfare and radar applications. What's different about this relative to existing solutions?
Great question. Thank you. Yeah, so this solution for the first time seamlessly couples real-time hardware-in-the-loop with the most advanced physics-based modeling and simulation software we call RFView. Typically in the past, if you were doing high-fidelity mod and sim, this was usually done offline during the design phase using high-performance computers, nothing real-time about it. But with the advancements of high-performance computing, we've been able to speed up the process and couple that with hardware-in-the-loop testing. In the past, hardware-in-the-loop testing usually was much lower fidelity than the offline mod and sim, usually consisting of a finite number of injected targets offset by, let's say, range, angle, and Doppler. But now with this technology, we're able to couple flight hardware, the actual systems that are going to go fly into this virtual reality, high fidelity physics-based mod and sim. It's all kind of made possible through some mathematics as well. We use a Green's function formulation, which really helps with the implementation.
So tell me more about ISL's RFView modeling and simulation software. This seems to be a key in creating highly realistic test environments.
Yeah, indeed. Long history here. So RFView, as we call it today, really has a 30-plus year history. The scientists and engineers at ISL, beginning in the late 80s, early 90s, began to see the need to do much higher fidelity modeling of radio frequency propagation in support of very advanced developments, especially in radar and electronic warfare. And over the years, the need for that has clearly grown. I think everyone recognizes that. So we've had a lot of experience in working multiple frequency bands from, let's say, VHF up to X-band and KU, and vetted that with experiments as well. The good news for everyone else is that it's now a fully commercial product. It's available online. There's a cloud version, which is really ideal for students and academic research. And then there's a standalone application, which is ideal for the heavy hitters and people doing classified work. Just to kind of give you a sense of what sets it apart, it's all about open air propagation over hundreds, if not thousands of square miles, land, sea. We use high fidelity and highly accurate terrain databases and things of that sort to support anything essentially RF in the bands that we talked about. So that's radar, electronic warfare, and other electronic support measures. This really is key to supporting a whole set of digital engineering tools, especially this whole new concept of an RF digital twin. So folks can learn more about all of this at our website. There's a link to RFView there.
So you mentioned digital engineering. Can you elaborate a bit on ISL's offerings in this area?
Yeah, this is very exciting because, in the past, as I mentioned, there was this dichotomy between high fidelity offline mod and sim tools and then everything else, right? Hardware in the loop, prototyping, maintenance, mission planning, training. Well, we've figured out how to take that high fidelity physics model and use it throughout. You can think of it as the digital twin, for example, and use it throughout the whole sustainment process. So this is really plays in beautifully with the digital engineering revolution that's taking place, especially in the Air Force. You might have seen talk about the new B-21 and the next generation air dominance fighters as examples of using digital engineering. Well, we're right there supplying that capability for radio frequency applications. And I'll point you to a public domain AFRL SBIR success story press release that was released in the fall of 2018. That's available online as well. You can learn a little bit more about some of what we were doing in this digital engineering regime.
Yeah, ISL is a big success in that area, so good job. So lastly, how has your background at DARPA influenced the development of RFView product family?
Yeah, that's a great question. Again, I alluded to this. It's about 30 years now. We have been really trying to push the digital solution side of advanced radar, electronic warfare. When I was at DARPA in the early 2000s, I was a newly minted DARPA program manager. I started a program that was called CASPER, which stands for Knowledge Aided Sensor Signal Processing and Expert Reasoning. And it really was the predecessor to what we now call cognitive radar. And what that's all about is operating in extremely complex, dense, RF dense, congested, and contested environments and battle spaces. And to be perfectly blunt, the traditional statistical models that you could find in standard radar textbooks just were not good enough. So we needed new tools. And that was really one of the key beginnings of what we now call RFView and what we call Artemis, the hardware in the loop, and the training systems, and it goes on from there. So it's not surprising then that we're right smack in the middle of all of the activities associated with next generation cognitive radar and electronic warfare.
Yeah, it's been a long road, but it's paying off. Okay, thanks, Joe, for talking with me today about ISL's RFView. It's a new advanced hardware in the loop RF test system for radar and EW. I did record part of your keynote at NI Connect, so I'll put a link to that in the description here. To our audience, you can find more interesting interviews at videos.microwavejournal.com. Thanks for watching.